Now let's create the handles for our door panel. We will also do this in a separate family. Select the Metric Generic Model Face-Based template and click Open. Inside this template, there is a special object that shows conditional geometry. That is, for us, it kind of imitates the door panel on which the door handles will be installed. The upper face of this object corresponds to the door panel face on which we will place the handles. We are on the floor plan, and it is the upper face that we see. But if we open the 3D view, we will see a rectangular parallelepiped. Naturally, this object will not be displayed when loading this family into the project or into the parent family. It is conditional, like for example a wall in a door family, and is only needed for ease of modeling and understanding how our own geometry will interact with geometry on which it will be hosted. I will close the 3D view and return to the floor plan. Create a reference plane here that defines the door handle length. Whenever we shape any object in Revit model space or just select something, the program shows us the temporary dimensions. Temporal dimensions help us understand how far an object we have selected or just created is placed from other nearby objects, but also with them we can control the position of the object. I can click on the number and change it. I will set this to 200 mm. And the reference plane will move. The temporary dimension will disappear as soon as we deselect the object. But it can be turned into a permanent one. To do this, click on the small symbol below it. The color of the dimension line changed to black instead of blue. This means that the temporary size has become constant. You can also move objects through constant dimensions, but they don't disappear after deselecting. In addition, you can establish dependencies through permanent dimensions. We have already set them many times by assigning parameters to dimensions, but you can also assign a fixed dependency by simply closing the lock under the selected size. Such dependence will mean that the object is attached to another, one strictly at a specified in the size distance. If one object moves, then the second one will follow it, keeping this distance. In this case, the central reference plane is pinned. You can see this if you select it. A special pinning symbol appears. Pinned objects cannot be removed. And since this plane cannot move, then if I try to shift the second one attached to it, the program will give an error. That the dependency I have set is not being accomplished. In case of such errors, I have two options. Remove the dependency that I violated by this action, or cancel the action itself. I will cancel the action. I need a dependency. I will create a base for my handle. This will be the extrusion element. And the base will be rectangular. I will snap the sides of the rectangle to the reference planes. And I will set a parameter that will determine the dimensions of the base. Both dimensions will be the same, so you can use the same parameter. I'll name it A and make it an instance parameter. I will set the extrusion height to 10 mm. if this parameter of the extrusion element is not associated with any of those of the family, then this value can be considered constant, since when we load this family into the parent, we will not have any mechanism to change this value. I'll finish building the extrusion. Next, we will create the door handle itself. I will do it with a sweep. I'll go to the elevation view and build the path. I need this line and horizontal one. I will determine the height for the horizontal line. Here you can snap to the face of the object, but it is better to do it with the reference plane. The dashed dot line shows the level. Press the Tab key to highlight the plane and snap to it. Select the line and set the size value to 70 mm. Also close the lock. The size will be constant. This line should also be snapped to the reference plane. Let's do it through the Align tool. Now we need to create a profile. I will activate the Edit Profile command. The program will offer us some views where this profile can be created. I will go to the floor plan. The profile will also be rectangular. Parameterize it in the same way as the door handle base. The dimensions will be determined through the parameter, which I will call b. Let's complete the profile and sweep construction. And go to the 3D view. Let's specify the parameter values. I will point out that a will be equal to 60 and b will be equal to a divided by 3. This kind of relationship works in both directions. That is, if I change the value of b, the value of a changes, and vice versa. When there is more than one parameter present in the formula, the dependency will no longer be two-sided. In such a situation, the parameter value for which the formula is written will simply be locked and will change exclusively in accordance with the formula. Let's create a parameter for the door handle material. I will select both objects. Find the material parameter in their properties and use the Associate Family Parameter command. Then create a new parameter. Name it Door Handle Material. Since the family is nested, let's make this an instance parameter. Let's change the category of the family. Select Doors. And set the subcategories for the objects. You can use one of the existing subcategories or create your own. There is no standard subcategory for hardware. I will use the same one as for the door panel. Let's save the family.